What if every aircraft, factory, and human had a perfect digital copy? A twin that predicts failures before they happen. That future is not science fiction. It is being built right now. Welcome to your SASE gateway. Today we explore digital twins. They are virtual replicas that mirror real-world systems in real time. From jet engines to smart cities, digital twins are reshaping how we design, maintain, and secure technology. By the end of this video, you will understand what they are, how they work, and the new security risks they create. A digital twin is a live model of a physical object. Sensors feed constant data into a simulation. That simulation predicts performance, detects issues, and tests updates before they reach the real world. Think of it as a living dashboard that learns and evolves with every data point. In aerospace, digital twins track engine wear. In manufacturing, they monitor robots and production lines. In healthcare, they model human organs for safer surgery. Digital twins close the gap between design and reality. They cut downtime, reduce waste, and allow instant troubleshooting. An aircraft twin can alert engineers about a future failure days before it happens. A factory twin can adjust workflow automatically to avoid bottlenecks. Even cities are using digital twins to manage traffic and energy grids in real time. It is data-driven foresight on a global scale. The power of digital twins comes from AI and the Internet of Things. AI reads the sensor data, detects patterns, and learns what normal looks like. When behavior drifts, the twin warns operators before failure. As more devices connect, twins become smarter and more autonomous. They start to optimize themselves without human help. Every twin shares data with its physical counterpart. That data can include control signals, machine states, and sometimes confidential blueprints. If attackers compromise a twin, they gain insight into the real system. In an industrial plant, a fake twin could feed false data to operators. In aviation, it could hide early signs of failure. This is why digital twin security must include strong identity controls, network segmentation, and real-time monitoring. Zero trust principles apply here too. Never assume your twin or its data is safe by default. Step 1, protect sensor data with encryption and authentication. Step 2, separate operational networks from cloud analytics. Step 3, monitor API access between twin and asset. Step 4, audit all changes in model behavior. Step 5, train teams to detect anomalies in both digital and physical outputs. A digital twin is only as safe as its data pipeline. Digital twins will transform every industry. They will predict, prevent, and optimize everything we build. But every new connection opens a new attack surface. The future of computing depends on how we secure these virtual mirrors. Comment with your thoughts. Are digital twins the next great leap forward or the next security nightmare? Watch my video on serverless security next to see how cloud logic and digital twins are converging fast.